This is the 4.1 to 4.2 review. Calculators are not allowed, and it's number 1 where the goal is to find the absolute minimum value of f. So this is asking us for a y coordinate that comes from the location for which we have an absolute min. So this is going to require us to go through all 6 steps of our process, where we first say what the domain is. So looking at all 3 of these, we can see that there's no division, there is no even roots, and B, it looks like we're going to have a log that we've got to pay attention to, but the other 2 will be all real numbers. So we can do this for all 3. On this one, since x is inside the log, that x must be strictly greater than 0. And for C, the domain again is all reals. Okay, the second step for each of these is to take the derivative so that we can find the critical values. So looking here, f prime will be e to the 3x times 3 minus 4. On this one, my derivative, I'll have to use the product rule, so it'll be the first one times the derivative of the second, plus the second times the derivative of the first. And on C, again, I'll have to use the chain rule. The derivative will be 4 times x minus 3 to the third times 1 minus 32. Okay, now I don't have a calculator here. That means I'm going to have to find the x coordinates that make these 0 or undefined. So first I'm going to simplify. And on this one, I'll get an f prime of x equals x plus 2x ln of x. And here, I'm not going to multiply that out, because eventually my goal will be to isolate x. Because what we're going to do now is we're going to set these equal to 0 or undefined for each. Now for the zeros, that means I need to set this equal to 0 and isolate x. So I'll move the 4 over, move the 3 over, log both sides. So I'm going to do just a couple of those at a time. Move the 4 over, divide by the 3. Now I'll log both sides. And then I'll take 1/3. So here's my critical value for part A. On part B, probably the technique that will work best is it'll only be undefined when x is less than 0, and that's not in our domain, so we don't need to worry about it. And then the other piece, in order to figure out when this equals 0, I'm going to need to factor. So I'll pull out an x, and I'm left with a 1 plus a 2 ln of x. That needs to equal 0. So either x will be 0 or 1 plus 2 ln of x will be 0, which would be the same as saying ln of x is a negative 1/2. Or now if I raise both sides, make them powers of e, I will get x equals negative 1 over, e to the negative 1/2, which is the same as a 1 over root e. So on this one, my critical value was 1/3 ln of 4/3. On this one, my critical value is x equals 0, but that's not in the domain, so I can't use it. Or x equals 1 over root e. The next one, if I isolate x, I have 4 times this x minus 3 to the third equals 32. Divide by 4. Then take the cube root, and then add 3. So I found my critical values. That's step 2. Step 3 involves creating a sign chart for the derivative. And on that sign chart, I'm going to put the domain, which is all reals, and the critical point, which is this 1/3 ln of 4/3. Same thing over here, except I need to have that domain on there, so I can't use anything to the left. And I've got a 1 over root e. And on this last one, Domain's all real, so the only thing that goes on is the 5. Okay, now here's where being a smart test taker kind of comes into play. Notice that the goal is to find the absolute minimum for all 3 of these. And I only have one critical point for each. So unless the test says nothing, there is no absolute min, we can probably assume that this is going to be negative, then positive, negative, then positive, negative, negative, and then positive. So I'm going to tell you right now that I'm not going to make you choose numbers smaller than this and plug them in, because that would be a little tedious, and this is a multiple choice problem. I might do that on a free response, but on this one it's not going to be necessary. So it turns out that all 3 of these are locations of minima. So what that means for you, what you're going to have to be careful for on this particular problem, is that you don't give me the x coordinate, because those are not the minimum values of f. Those are merely the locations of the minimum values of f. So in order to get the actual value out, we need to plug this critical value into the function. So I'm going to see that I'm falling then rising, I'm falling then rising, I'm falling then rising. So I will get mins at each of these values. So for step 5, I will say f of 1/3 ln of 4/3. That's going to be my min. Same here will be f of 1 over root e. Same thing on this one, f of 5. So we've got to plug those in. If I plug e, or 1/3 ln of 4/3 into this, I get e to the 3 of these minus 4 of these. Notice that the e and the log will cancel. I'll end up with, end up with a 4/3 minus a 4/3 ln of 4/3. And that's how I leave the answer. On this one, I have to plug a 1 over the square root of e into x squared times the ln of that number. So, squaring this, I get a 1 over an e. This one I'll have to work a little bit harder. This is the log natural of e to the negative 1/2. The ln and e will cancel, so I end up with a negative 1 over 2e. And last but not least, I'm going to plug 5 into this function up here and multiply it out. I have 5 minus 3 is a 2 to the 4th is a 16, and a 32 times a 5 is 160. So subtract that and I get a negative 144. And we're done.